Now we'll have a brief introduction into descriptive statistics. So let's start into that deep dive. So when you're talking about descriptive statistics, you basically have some key things which you have to talk about, which includes central tendency, so measures of central tendency, and measures of dispersion. We'll talk more about measures of central tendency as of now. So what is central tendency? Basically, the word itself defines that there is a tendency of data to move towards a central portion, right? And that's what we're talking about. So when you look at data, if it is coming out of a natural process, say for example, if you talk about age, right, which comes from natural, you don't cook up this data, right? So age of a person is coming out of a natural process of aging, and if you take huge volumes of data, typically it will follow a tendency that bulk of the people will try to come to the mean value of the average value, right? So we have been talking about average values quite often without actually understanding what it means. So average talks about where the bulk of the data is concentrated, right? So if you talk about salary of people in an organization, and if you try to take a mean value or the average value, it basically talks about, on an average, what is the value of salary which most of us get in that company. That is what we are talking about. Median, on the other hand, is like partitioning the data into two equal halves and just getting the central portion. And mode basically means what is the highest frequency of salary which you can observe in the data, right? And then it's measures of spread, which is also called of measures of dispersion, wherein you have range, quartiles, percentiles, deviations, variance, and standard deviation. Then you have measures of symmetry and measures of pickedness. So we'll talk more about this as we go forward. So now we come to inferential statistics. So a brief introduction into inferential statistics. So inferential statistics are techniques that help us to make generalization about population by drawing some small sets of data from the whole population. Now, first of all, you need to understand why is this important. This is important because now since today we are in a heavy compute, heavy storage phase wherein data is not a problem, but the basic example or metaphor which I would give to explain this is that why do we take samples? So you go to a doctor and the doctor says that he is doubtful that you have, say, something like you may have contracted something like malaria or cholera. He's not sure and he recommends you to take a test at a diagnostic center. You go to a diagnostic center and imagine he takes out your whole blood out of your body. Now, is that advisable? No, because it will destroy you, right? So what you expect is that if he takes a small sample of your blood, does that test, and based on that you can reasonably do some inference about the whole body, right? And that is why you do sampling. Now inferential statistics talks about whether my estimates are really close to the population and whether I can make generalization about the whole population. That's inferential statistics, right? So it's about estimation of parameters and testing the statistical hypothesis underlying them. Some hands-on the descriptive statistics part. So let's use an internal R data. So let me do this way. Let me just not write it in the code file and directly write in the console so that I actually see more of this. So I'm going to load a data that is the empty cars data, and then we can do something like summary on empty cars. So basically get stats related to everything. So you're getting something like the minimum value for miles per gallon, the first quartile, the median, the mean, the third quartile, and the max values, right? Similarly for all of these you would be getting, right? For cylinder, displacement, horsepower, drivetrain ratio, weight, cubic, right? All these variables, right? Now if you want specifically for one variable, then what you'll do is you'll do a summary box bracket and empty cars, and you can use it with a dollar reference like this, wherein just pass which variable you want to have a look specifically this way. Let me check the class of the data. It's a data frame, so this should work. So empty cars dollar mpg, or else you can also do something like this, where you can use a box bracket, and inside that you can give the reference of the variable you're trying to access. So it could be mpg like this also, right? So both end up with the same. So I'm just going to clean this. Okay, so now if you want to do this separately without using the summary function, so you can use some functionality like max, and you can obviously pass whatever you want. So I'm just going to say attach first and attach empty card, so that you don't have to give the reference of all these again and again. I can directly access the variable. So I can say max of, say, miles per gallon will give me max value. I can do a min of mpg, right? I can do a mean again of mpg, right? I can do a median mpg, right? I can do variance of mpg, right? And I can do a standard deviation again of mpg, right? I can do a summation of mpg, and so on, right? And I can say detach and detach the actual empty cars package, so that it's not freezing my memory. So we have already done all these things, right? So let's go on and do some more functionalities. So you have one more package which will let you do something similar to that. So I can say library, but you'll have to check whether this is installed. So it's called pyc, but it's not installed, so we'll have to install it. So, or else you can just use some other package like hmic. So now this is also not available, so you need to install it. So there are a couple of functionalities which are available in the psych package, as well as it is available in hmic package. So you can install any of these. So say saying pych. So once installed, you can use the functionality describe, which is already available in this package. Right, and then you can say library psych, and then you will use this describe functionality, describe, and you can say empty cars. So you'll be getting, for each variable you'll be getting the number of observations, the mean value, the standard deviation, median, the trimmed value, the mean absolute deviation, the minimum value, max, range, skewness, kurtosis, and the standard error. Right. So now let's go for standardization of a variable, the basic commands which we would typically use for this. So when you are looking at standardization of the data, you would be doing an x minus x bar divided by standard deviation of that variable, right? So that's what you do. So if you have to do a standardization, but first let's understand why is it required. So let's try to do a plot of something like, say, miles per gallon. So if you say plot, say, the data, which is empty cars dollar miles per gallon, if you do this, this is what your data is. If you do a histogram of this, that's how the data looks. Right now, if I want to do a standardization, what I do is I'll create a new variable, say IMPZ, and I'm allocating something like this, wherein I'm saying miles per gallon. Obviously I'll have to give the reference as empty cars, because I have said detach miles per gallon minus mean of empty cars dollar miles per gallon, right? And this I would be dividing by the standard deviation of empty cars dollar miles per gallon, right? And this I'm going to allocate somewhere else, right? So I'm not writing it in the main data, I'm just writing it in IMPZ, and I'll run that, right? And now if I do something like a hist on IMPZ, right? Okay, sorry for that, just said. Now you'll see the distribution. So the histogram of IMPZ, although it's a data derived from uh, empty cars, it's comparatively different. So what you have done is you have standardized it. So you, if you can look at this base, right, over here it was from 10 to 30, and now when you're looking at over here, you have moved the distribution to center around the mean value of 0, right? That's what you have done, right? So that is called as standardization, right? So if you observe the mean value, so if you say mean of IMPZ, obviously it's around 0, that is e raised to minus 7. So you can see that over here also, right? And if you look at the standard deviation SD of IMPZ, that's 1. So when you have done the transformation of standardization, right, what has happened is that the mean has shifted to 0 and the standard deviation has become 1, and that is called as standardization. Now to do this on a matrix or a data frame, we use a command called a scale, right? So if you want to do the same on, so first of all, let's attach empty cars, right? So that's got attached. So IMTZ, and I'm saying just do a scale on MPG, right? So I've just done that. So I've done centering around the mean and scales by the standard deviation, right? So IMTC, it's a new variable you're creating wherein you're saying scale, wherein you're saying miles per gallon, and you're saying scale is equal to false. So you're saying that you don't want to do the scaling, right? Now if you do the description, or even if you do the plot, so let's do a histogram of IMPZ, right? So that's how it is. And if you do for C, it's like this, right? So you have not allowed the scaling in case of IMTC, whereas you have allowed the scaling in case of IMTZ, right? So you can do it this way also. Again, 10 different ways of doing the same thing in R, so you don't need to be bogged down by that as to what is difference in over here. It's basically the same thing, right? Okay, so you can also observe the real data by using the describe over here on IMTZ as well as on IMTC, right? So you need to check the mean, both are 0. The standard deviation in this case is 1. It's 6.03 over here, so that's because you have set scale is equal to false, right? So the standardization has happened, so the centering has happened in this case with the mean value 0, but the standard deviation is 6, so it's not standardized. In this case it is standardized with the 1 value. Okay, I'm just going to clean this off. Okay, now you can do simple graphical descriptions using a stem and leaf diagram. So let's try that also. So use the stem functionality and say empty cars dollar miles per gallon, right? And do that. This is how the stem and the leaf diagram will come. So it says that the decimal point is at the pipe itself. So 10.44, 12.3, that's how you read this, right? So if you want to generate a stem and a leaf diagram, this is the way you do it. But a stem and a leaf diagram is a bit complicated to interpret and doesn't make sense. Rather describe them graphically and it makes more sense. Just going to clean this off. Now the box plot is pretty much a very useful way of representing data when it comes to descriptive statistics. So if you're trying to see the median, the first quartile and the third quartile, the minimum and the maximum with reference to a graphical representation, this makes more sense. So if you can just use box plot box plot, and inside there you can just pass mpg as a data. So that's how your box plot will come, and you can see it over here. I'm just zooming it for you. So this dark line over here is the median value, this is the first quartile, and this is the third quartile, and these are the whiskers, which are the extreme limits when you look from the standard deviation perspective. It's max and min. So bulk of the data, that is 50% of your data, is over here. Now this has a lot of statistical reference and perspective which you need to be aware, right? But as part of your course we are strictly laying more emphasis on how to use this from the art perspective, right? So basically, when you talk about different partitions of data, you have something which is called as percentiles, which basically blocks your data into 99 different segments, so that your data gets segregated into 100 equally distributed data points. And when you look from the decile perspective, it basically bifurcates your data with 9 points into 10 equal halves. If you look from the quartiles perspective, the quartiles basically block your data into 4 equal parts, right? And when you look at something like your median, which is second quartile, basically partitions your data into 2 equal halves. That's how we look. So if you look at the box plot, the first quartile basically partitions your data into something like, from that point, 25% of the data is below that and 75% is above that. The second quartile, that is median, partitions your data into 50-50, and the third quartile partitions your data into 75 below that point and 25 above that point. That's how we'll have to look at the data. Now, we have already used the histogram. Again, I'm just going to blow that up for reference. So histogram, and then without using, I can just say MPG because we have attached the data. So this is the histogram of empty cars. Now you can do a plot of various things, like just assume that plot of, say, if you say Forbes, I'm not sure whether this will come up because we have not attached the data, and yeah, it will be an error because this data is not already there, right? Yeah, so if you want any data, you can just go on and just have a look over here. So right, so incidentally, Forbes is not part of the regular thing, but yes, you can say this could be one, Florida. I'm just digressing a little bit. First, you need to check what is the data, so I can say summary of Florida, and then I can do something like this, a plot over here. I can say plot, say Florida dollar, say Phillips. Right, now this would be a generic plot. It's not, because these are some levels in the data, index data. So based on the data which you're passing, it will automatically take the type of chart, right? And it will be different every time based on the data, right? Okay, so we'll move ahead. Just cleaning up the screen and also cleaning up the data over here. So now let's do some interactive multiple plots. So I'll be needing some of the library files. So you'll install activate. We have already used this somewhere before this. So iPlots, attach the empty cars data, right? And then to a ihist mpg. So if you do an ihist mpg, right, that's how your plot will be. So it's interactive. You can click over here, right, view, right. So multiple things which you can do, you can explore at your own time. And then you can have the I bar, which is also interactive, and just pass something like CRB, right? So you can just code that. So this is how your output is. You can do an I plot again of something like MPG. Now again, it depends upon how you want to show them, right? So sometimes you might show some irrelevant variables also. So I've done an I plot. I can highlight these points. So I can do a large point, click it. I can say same scale, so I can change the scaling also at runtime in the scatter plot. So that's also possible.